Let's talk about finding an altitude, very specifically, finding the altitude of a right triangle using the geometric mean. So we discussed this in another video about how we can use these geometric means to find altitudes of right triangles. So let's just run through a few quick examples showing you how to do that. So first, let's talk about a theorem. So here's our theorem, the altitude geometric mean theorem. The length of the altitude is the geometric mean of the lengths of the segments of the hypotenuse of a right triangle. So talking about right triangles here. So let me grab an image so I can show you. So what this theorem is saying is that the altitude of this right triangle, so this right here is the altitude, is drawn straight down to the hypotenuse side of my right triangle. The length of this altitude can be found by finding the geometric mean of the lengths of the segments of the hypotenuse. So the hypotenuse is this side of the triangle, the longest slanted side, if I were to place it on its base. So the segments of this hypotenuse are x and y. So to find that altitude, I find the geometric mean of x and y. That means multiplying x times y and finding its square root. This idea comes from the fact that when we draw an altitude to the hypotenuse of a right triangle, it divides this triangle into two triangles that are similar to each other and to the original triangle. So we have this triangle over here, triangle 1, and then triangle 2, and then the whole triangle is triangle 3, and they're all similar to each other once we draw in that altitude. Since they're similar to each other, we can write a ratio of x over the altitude, ALT, which again is this middle part right here, equals the altitude over y, cross multiply. So the altitude squared equals x times y. To solve for the altitude, I would square root both sides. So that means the altitude equals the square root of x times y. So this here is just a proof of why this theorem works. So let's go back to this theorem and give it a try. Finding the geometric mean of the segments of the hypotenuse to find the altitude of these triangles. All right, here's problem number 1. My instructions say solve for x, which here is my altitude. The segments of my hypotenuse are 12 and 5. Remember, this bottom part here is my hypotenuse. The two segments, or the two parts of my hypotenuse, are 12 and 5. So to solve for x, I simply find the geometric mean of 12 and 5. So x, my altitude, is going to equal the geometric mean, which I find by drawing a square root and multiplying those two segments together, 12 times 5. 12 times 5 is 60. 60 is not a perfect square, so I have to simplify that radical, recalling my perfect squares list. So what number here on my square root list is a factor of 60, looking at the numbers on the left of this list. 4 is a factor of 60. Sorry, there we go. 4 is a factor of 60. So we can separate 60 into 4 times 15, because 4 times 15 is 60. Okay, I can separate that into radical 4, radical 15. take the square root of that first radical. The square root of 4 is 2, and that 15 stays underneath my radical. If you need more help with simplifying radicals, so 2 radical 15 is my final answer. And if you do need more help getting from radical 60 to 2 radical 15, simplifying that radical, just go back and rewatch the video, Simplifying Radicals, to help you get there. So the length of this altitude is 2 radical 15. So let's try another one. So number 2, my instructions again are solve for x. So x is the altitude, and then the 2 segments of my hypotenuse are 4 and 9. So to find x, you find the geometric mean. So square root, and then multiply these two numbers together. 4 times 9. 4 times 9 is 36. Oh, this one's nice. Since 4 and 9 were both perfect squares, 36 is a perfect square. Square root of 36 is 6. We don't have to worry about simplifying the radical since 36 is a perfect square. X is 6, and we are finished. All right, let's try number 3. All right, number 3. Again, solving for x, that altitude. This one's a little bit different. We need to be cautious here. A couple of things to notice is that 30 is the entire length of the hypotenuse, and 6 is one segment of the hypotenuse. So our theorem states that the altitude of this right triangle is equal to the geometric mean of the lengths of the segments of the hypotenuse. Here we don't have both of the segments of the hypotenuse. We only have one segment, which is 6. So that's segment number 1. And then to be able to find the geometric mean, we also need to have this segment. So since we have the total length of the hypotenuse, take the 30 minus 6, and that will give us the other segment of the hypotenuse. So 30 minus 6 is 24. So we can go ahead and fill in that this segment of the hypotenuse is 24. And then we're going to forget about that 30. So we just used it to find the 24. So this one's a little bit different since they didn't give us the 2 segments. They gave us 1 segment in the total. Take the total minus 1 of the segments to get the other segment. Now we can continue as usual. X is the square root of the 2 segments of the hypotenuse. 24 times 6 multiplied together. 24 times 6 is 144. That is a perfect square. So hopefully you know it, or you could put in your calculator, the square root of 144 is 12. So x equals 12. So again, finding the altitude of a right triangle using the geometric mean. If you need some help with number 1, simplifying that radical, just go back and watch the videos. You can watch the video of geometric means, the video of simplifying radicals, and those will help you with today's lesson.